Okay, here we go. A 1,000 kilogram car moving west at 12 meters per second collides with a 3,000 kilogram truck moving east at 17. The cars stick together and move as a unit after the collision. Find the speed and direction of these two cars after the collision. Okay, so initially when I'm reading this, I'm thinking the exact same thing, right? It's just like what I did. I've got a car, I've got motion, they're hitting each other. But here's where it changes. Here's what's different. This one's asking about like a force and a time interval. Like this one's talking about impulse. This one's not. Like there is an impulse, right? There's a force applied for a time, but we don't know anything about the force. We don't know anything for the time. What we do know is what happens to each car. See up here, we didn't hear anything about like what happens to the, like we were just applying a force to the car. We weren't hearing about anything with the deer, anything with the road, anything like that. We're just looking at what's applied to the car. So in this case, we're talking about what's applied to both things. And as soon as I see that, as soon as I'm like, oh, more than one thing, that's this one here. Again, assuming there's no force applied, no time interval that's talked about here, this is the equation I'm going to go with, which is conservation momentum. So the momentum of the car and the truck before they hit have to be equal to the car and the truck after they hit. Okay, so that's what's going on with this one. So a big part of these problems is figuring out, like, how do I know which equation to use? Okay, and that's how I figure out for this one. That's how I know I'm using that equation instead. And the way we kind of wrote it originally, we introduced it like this sigma pi equals sigma pf. Basically, the total momentum before equals the total momentum after, which is what this is. So total momentum before equals the total momentum after. We're just adding all the values together. Remember, momentum is P equals mv. So when I'm setting this up here, I've got a car going west and a truck going east, and then they stick together after the collision. So here's my truck going east. Okay, he's going east at 17. Okay, and here's my car going west at 12. Okay, so I'm going to call MT for mass of the truck. You could call it M1, M2, however you want to do it. I'm just going to separate them this way. So mass of the truck is 3,000. Okay, mass of the car is 1,000. Okay. The truck is initially going at 17, so V truck initial is 17. The car initial is 12. And then they stick together, so I don't know the final of the truck. I don't know the final of the car. Okay. Before we go any further, I did something wrong. Anyone know what I did wrong? Excellent. What? One of the signs needs to be negative. Why? Bingo! Hey, anytime you see bold words, there's a reason they're bolded. So I put east and west in bold. The reason is I want you to see that they're opposite directions. And if the directions are opposites, something's got to be negative. Okay? Now, I usually make west negative and east positive, so I'm going to make the car negative and the truck positive. Now, if you did it the other way around, you would get possibly an opposite answer for me. So, like, if I get a positive answer, you would get negative. If I got negative, you would get positive. on the final, like, it should be clear. Either I will tell you which direction is positive, or like all the answers will be negative, or all the answers will be positive. So you shouldn't run into the issue where like you picked left for negative and I picked right for negative. Like, that should not be the issue. You'll want to be careful with that, but it's just something worth mentioning. I try not to make that the reason why you get something wrong. Okay, so the equation we're looking at is this conservation momentum, total initial momentum equals the total final. So what I do is I find all of these. I find my initial momentum for the truck. I find my initial momentum for the car. I find my final momentum for the truck. I find my final momentum for the car. Okay? And all I have to do for those is MV. Momentum's always MV. MV, 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 MV. So the initial momentum for the car is going to be 1,000, or for the truck, 3,017. 3,017. Okay. Gives me initial momentum for the truck of 51,000. Okay, car, 1,000 times negative 12. Okay, gives me an initial momentum of negative 12,000. Okay, so far so good. Okay, now we got to do the final of the truck. Mass times velocity. Well, I don't know the truck's velocity, so I just call it VT final. And the car. Mass times velocity. I don't know it, so I just call it VC final. Okay, well, here's the problem. The problem is I got two unknown variables, and I have one equation. Right? This is the only equation we talked about. Got two variables, one equation. And that's not possible to solve. If you got two variables, you have to have two equations. Or I need to change something so I only have one variable. Okay? What am I missing? I'm missing something here in the problem. There's a very specific thing it told me in the problem that will solve this whole thing for me. Yeah, come. They stick together. They stick together. If two things stick together, if I hold a stapler while I run, because obviously that's how things roll. If I hold a stapler while I run, and I run at 10 miles an hour, how fast is the stapler running? 10 miles an hour, same speed as me. So, if the truck and the car stick together, they have the same final velocity. They have the same final velocity. So I'm going to make a really small but really impactful change. I'm going to cross out the T. I'm going to cross out the C. And I'm just going to call it V final. I'm just going to call it V final. So now I'm ready to put everything together. Now I'm ready to add all these momentums up. Okay? So, initial momentum of the truck, 51,000, plus initial momentum of the car, negative 12,000, equals final momentum of the truck, plus final momentum of the car. Okay, 39,000, 3,000, 1,000, but they both have VF, common denominator, or common term, like terms. So you add them together, you get 4,000 VF. Divide both sides by 4,000. And you get VF equals 9.75. And there's your answer. I want to know how fast are the combined vehicles going. Well, after the collision, that's how fast they're going together, 9.75 meters per second. It's a positive number, which means it's going right. Which makes sense. There's more momentum to the right. The truck is heavier and it's going faster. So it makes sense that they go to the right after they collide. Now again, on the final, you're not going to be required to show your work. I would encourage you to show your work, but you're not going to be required to show your work. So like, if you're like, well, this is just a lot of stuff, well, you might be able to figure out these, write these down, and then it may be obvious to you, oh, I just add the masses together and call it VF. Like that may be, like, again, I'm doing like all the steps. Some of you may be able to do shortcuts here and there where you combine some steps together, and that's totally fine. Again, I want to make sure you guys can do it, so just make sure you're able to get through it and solve it, and you should be okay there. Okay, any questions on number 11? Okay.